Over 2,000? Over 5,000? Over 10,000? Hey. So we got one hand left. How much was it? And how did you explain that failure? That's always a good, I don't know, I took it out and it just didn't work. Oh, really? ESD testing? Well, that's better than my excuse for blowing them up. As you can see on the slides here, I'll have everything up on eLinux. I'll have the slides in PDF format and all the links to all the components and items that I've discussed here. I'll have those up later today. I've been doing booth duty, so I hadn't exactly got them all uploaded, but they will be there by the end of the day. This is actually going to be a fairly informal discussion or presentation. It's not going to be highly technical or anything, so it's more of just some of the things that I've learned over the years, and it's not a be-all, end-all of reviews of different components, but it's just some stuff that I have experience with and thought I'd share. So at the end, I usually leave 15 minutes or so for questions. Feel free to ask anything. It doesn't have to be on the topics of the items that we've discussed in the presentation. Anything with open source hardware, open source tools, any of that, I'll be happy to discuss. And if we run over time, you're welcome to visit me at the Miniboard booth over in the exhibit hall. We can be happy to spend any time I have to answer any of your questions. I think we'll wait another minute or two to get started. No, I'm good. Yeah, I'm good. Yep. I usually like to pass it around. Yep. Absolutely. If you okay, got it. Gotcha. If you would, you're going to be here in the back? Would you give me a kind of sign at 30 minutes in? Like it. No obscene gestures, though. Hope everybody's had their coffee this afternoon. If you would pull the door to back there as well, thanks. So we'll go ahead and get started. And again, all the slides in PDF format will be up on the wiki page later today, as well as links to all the different materials that I've discussed. My name is Dave Anders. I'm also known as Purple Plague on social media, as well as IRC and other places. I'm currently employed by Intel as part of the Open Source Technology Center, and specifically part of the Miniboard project. We have a booth over there in the exhibit hall. Today's discussion is on inexpensive essential tools. One of the things that I've been doing as part of different development board projects over the years is we generally like to have inexpensive tools that we can take to hackathons and to work with our development platforms and things. So I've spent a lot of time going through and experimenting, trying to find out which cheap tools, not cheap, inexpensive tools that we can find out there that really do the job and are worth you actually spending money on. So one of the things that we're going to talk about is a couple low-cost logic analyzers and the software that can go with them. We're going to talk about some very low-cost oscilloscopes. They're handheld. We're going to talk about some features for multimeters, and we're going to talk about some microscopes, as well as some soldering iron stuff. And so we're going to go ahead and jump into it. Not everybody needs a $100,000 logic analyzer like the one that's listed here. Most of the time, if you're debugging I2C or SPI or even RS-232, a very simple logic analyzer will do the trick. One of the most popular ones over the last decade is the Cellular Logic. It's based on a USB chip called the FX2, which actually is, of all things, an 8051 processor with USB interface on it. Now, this particular one had 8 channels and can sample at 24 megahertz. It was very, very popular during the time period and generally sold for about $100. The particular company that's manufacturing, had been manufacturing it, has upgraded their designs and moved on to other products. But one of the interesting things is a lot of the Chinese and Indian companies have taken the design and created clones of them. So if you go out on eBay and actually you can find them on Amazon, eBay, Alibaba, half a dozen other places, you can actually find a clone of the original Cellular Logic device. And the funny thing is, they haven't even taken the name off of the design. They have it even on the documentation. So it's, I mean, it's truly a clone of the device. And there's tons of them out there, and they're all ranging in from the $15 to $25 range. And they're great for the price that you're paying for them. They've got 8 channels, which is more than enough for you to decode most things, the SPI, I2C, UART, even bit-banging GPIO stuff. So it's a very great buy. Another great purchase is the Openwork Workbench Logic Sniffer, and this is something that if you really needed more channels, this one will support up to 32 channels with a 100 megahertz sample rate. This one's $50 and it's an open source design and available through quite a few different places like Seed Studios and Adafruit and a couple others. So you've got several different logic analyzers that are out there, very inexpensive, that you can purchase. One of my concerns is that I'm very strong supporter of open source software. So anything that I purchase, I want to make sure it's compatible with my Linux distribution. And for the last 7 or 8 years, a particular software project called SigRock has been creating software to use these logic analyzers. And SigRock has a wide range of logic analyzers that it does support, including all of these Chinese clones that you can find. If you go to the sigrock.org website, they actually have a link to show all of their supported hardware that they know about and have tested. And they have a wide range of the Chinese ones listed there that you can find, as well as much more expensive ones. My personal recommendation, they have a little green check box or a red X indicating whether it's supported by SigRock or not. Don't buy one that's got a red X. If any of the ones that have a green check box, somebody has gone through and extensively tested. It works with Linux. It's reliable. It's a good component. So take the red X ones as a place not to go. The SigRock applications, again, it's an open source project, but it also has a lot of interesting features to it. It'll actually allow you to use your logic analyzer to decode the data that you're actually sniffing through. And it has a programming interface. It has several different ways that you can actually program your own decoders in there. So if you're running with CAN bus or if you've got a proprietary protocol that your company is working with for, say, an elevator or some other unique protocol, as a programmer, you can go through and create something to decode those values as you capture them. And there's a wide range of protocol decoders that have already been shared with SigRock and put out there in the open for you to use. So we're going to go ahead and move on to oscilloscopes. Most of this, again, just like logic analyzers, most people don't really need an extremely expensive oscilloscope unless you're debugging, you know, high-end HDMI or SATA interface. A high-end oscilloscope is really just not necessary for doing embedded development, especially from a software perspective. So one of the things I did was, as part of my duties, I actually purchased 27 handheld oscilloscopes. I went from eBay to Alibaba to every place I could find, Amazon, Micro Center, Fry's. I found every one I could find, and I purchased them and tried to do an evaluation on them. And I found that there was a wide variety that are out there. Some good, some bad, some okay, but there was a huge variety out there. And it's a wild, wild west for people trying to get your money for these particular devices. And with the maker community that's really exploded over the years, there's this market for people who may not necessarily know what features to look for in an oscilloscope and whether it will actually do the things that they want it to do. So I had some very tight guidelines that I wanted to use when I'm evaluating a small handheld oscilloscope. I wanted to make sure that I could use it to actually look at I2C signals running at 400 kilohertz. So that was very important to me. And so I had a particular product that had an I2C failure. So I was each one of the oscilloscopes I used to see if I could identify that failure using that oscilloscope. I also had a specific device that had a power glitch where the startup of the power sequence was very predictably a failure, and I wanted to make sure that I could identify that using the oscilloscope. I also wanted to be able to identify timing errors when something was not in sync with the rest of the timing. I also wanted to be sure that the advertised bandwidth for the device was actually what it actually was. The bandwidth generally is going to be how much the frequency at which you can actually determine a signal and view it. And there are various advertisements of that particular bandwidth. The question was, whether did they actually meet up to that standard? And also the sample rate. We wanted to make sure the advertised sample rate looked as accurate as possible. The clear winner out of all of these particular devices is the DSO 1112, which is the one that's listed here. It's a very interesting device. I disassembled it and went through pretty heavily just to look at it. And the device itself looks like it was manufactured by someone who actually knew about building oscilloscopes. It's by a company called JYE Tech. And once I started looking into them, apparently they do have some background in designing oscilloscopes, high-end oscilloscopes, but they've really started focusing on these lower-end ones that are really interesting. This particular one is battery-powered. It has a USB interface so that you can actually capture the data. It has a touchscreen interface. It has 2 megahertz bandwidth, which makes it very usable for looking at I2C at 400 megahertz. And it has a 5 million samples per second sample rate. It's just overall a really nice unit. The battery lasts quite a long time. It comes with two accessory probes. It also has a signal generator on it as well, so you can actually generate sawtooth, square wave signals on it as well. So from a resource perspective, this particular one is just phenomenal. And what really stood above all the other low-cost oscilloscopes that were on the market was the user interface. I've actually used $100,000 oscilloscopes, and the interface that's on this feels like a professional oscilloscope. if you sit down and use this interface, transitioning to a real high-end oscilloscope is very easy to do. The problem I had with a lot of the other ones were they had user interfaces that were very cryptic because they were trying to fit the user interface on a small screen. The wording on it was very difficult. Being able to switch between menus was very difficult. So while there's some others that are in the same price range that have the same feature set, this one just stands out to me as just really, really nice. This averages about $70. You can find it less than that on some places, but through Amazon Prime, $70, rock solid. And for me, this is very important. And again, based on our show of hands for software developers, this is a no-brainer investment for you to have on your desk to look at. It's less than $100. You don't have to worry if you accidentally short it out and destroy it. It's not that bad of an investment. And it's easily a great tool for you to look at issues from the hardware side. It's single trace. That was an item that I was going to point out here. There were two items that I talked to JYE Tech about on the design. It doesn't have a built-in stand. So what I've got a little cell phone stand that I use for it. And it doesn't support an external trigger. So in theory, if it did support external trigger, you could actually daisy chain these together and get dual or quad trace if you wanted to. So it's a very interesting design, and we did provide that feedback to JYE Tech. Go ahead. It is touchscreen. It's a 4-wire resistive touchscreen, and so one of the things, it does not come with a stylus. It works fairly well with your fingers, but I have big fat fingers, and so I actually went on eBay and bought a package of Game Boy DS styluses for like 50 cents. And so I have my cell phone stand, my Game Boy DS stylus, and my oscilloscope. So it works really well on your desktop, and from a software programmer perspective, it's a no-brainer investment. Let me answer that here. So, don't waste your money on some things, especially kits. The kits are basically worthless. Unless you're just wanting to put a kit together to practice your soldering, most of the time, once you're done with it, it's basically useless. The calibration on it and everything, just don't waste your money on them. They're a bad idea. I know they're tempting to get, but they're just not worth your time. Don't waste your money on the small AVR boards like this particular one. These are all over the place. They're advertised as dual trace. They are basically worthless. Yes, it will show a signal on there, but you cannot identify any failure points. And that was one of my test conditions. I knew this particular board had a power glitch. Could I identify it with the device? And I couldn't. So maybe you need some more higher bandwidth, dual trace. Two of the ones that are popular on the market are the quad DSO and dual DSO that are out there. There's a lot of different variations of them that are sold by Seed Studios and SparkFun and everything. They have the user interface that I really don't like because they're very, very cryptic. The cost of these are generally in the $150 for the dual and $225 for the quad. Unless you absolutely need to have this as a portable where you're taking it out onto a location, I highly recommend don't do it. And the reason I recommend that is because you can get a full-featured generic DSO for $200. And that's on eBay or Amazon or half a dozen other places. And for the money, for $200, you're getting more features like high-end frequency counting. It's easier to use because it's larger and it has better specs, higher bandwidth, higher sample rate. So from my perspective, unless there's a very good reason for you to have that as a handheld device, the money is much better spent on a real size professional oscilloscope. So, did that answer your question? Yes. Basically what was happening was I had 4 power supplies that needed to come up in a very specific sequence, and one of them was not very consistent on its timing. And and it was like 1 out of every 3 times I would power up, it would take like 200 milliseconds longer than it should have. And so I wanted to actually identify that, and the smaller AVR one just simply couldn't capture that short period and display it in any meaningful way. All the other devices generally did pretty well on it. So we're going to go ahead and move on to multimeters. And there's not much I can say about multimeters. There's a lot of them out there now. There's a lot of them that are actually supporting RS-232 and USB for data capture. It all depends on your needs and what kind of stuff you want, but most of the multimeters are generally that you can find less than $100, but generally more than $20 are generally extremely good. There's just no point in going through and testing all of them because they generally do what they say they're going to do. So if you need data capture, you can look and see if you can get USB or RS-232 support on that. So from my perspective, what's more important is the probes that you use with the multimeter, because normally the ones you get with the multimeter are generally useless. So one of the ones I recommend are basically called needle probes. And companies like SparkFun, Adafruit, Seed Studios, DigiKey, Mauser, all of these places generally will carry a needle probe. Now, you do have to be very careful with this. I've poked my thumb and finger many a time, because when they say these are needles, they are needles. And so why is this important? Because generally when we talk about most of the RoHS compliant PCBs and such, the solder that's being used on there is very difficult to get through a lot of times. And if you're usually using one of the cheap probes and trying to measure 2 points, maybe a joint that's been soldered, or to get on a test point, a lot of times the ones that come with the multimeter, you can't get through that. Additionally, if you need to probe a trace or a test pad that's actually covered with solder mask, you either have to take an X-Acto knife and scrape some of the solder mask off, or you can actually use a needle probe to poke through the solder mask. And it's these are very important, and they're only $5, and it's well worth your investment to make your multimeter much more usable. I keep several different sets around available, and again, they're very inexpensive, so I would recommend investing in a set. The other one that I recommend is a tweezer probe. This works very much like a tweezer, but each side of the tweezer is a different probe portion. And what this is meant to use is if you want to measure across surface-mounted resistors or capacitors, different types of devices, without actually having to use both probes together on both sides, you simply just squeeze on each side of the device. It's a very handy probe to have around, and again, it's only $5. And when you have that there, and you need to do a probe of a particular device, it makes everything so much easier. And when you're trying to move around and do 2 or 3 different things, maybe checking your serial console and hold this on the probe at the same time, doing it one-handed is with this particular set of tweezers is very nice. And of course, I recommend using Alligator clip with banana probe or banana connections on these. When you're doing a lot of measurements that are consistent, you're always connecting up, and you're doing your software development and debugging, you don't want to have to stop from working on your keyboard to move over and do the test probes or whatever that you're doing. The Alligator clips are very important. What I generally do for using the Alligator clips, I'll take a small piece of a wire and solder directly to the test point that I'm using. That way I can actually use the Alligator on that piece of wire. So there's a lot of different things you can do on there. Again, it's $5. For $15, you can get an entire set of things that make doing your measurements a lot easier. and instead of just depending on the probes that came with your multimeter. And so as we were looking at with the Tweezer probe, there's actually an additional type of multimeter that I keep around. And this is basically an SMD meter. And it's a variation of the probe tweezers that I showed earlier, but it actually has the multimeter built into the tweezers themselves. And this is just absolutely great for finding resistor values on boards that have been populated improperly. It also does inductance testing and capacitor checks. So it's a pretty interesting little tool, and it's great to have around. It's $30, so it's really a good investment to have on your desk. So I'm going to go ahead and move on to microscopes. This particular one is actually one that I have. It's a stereo microscope, and it actually comes with several different lenses and a snake light for doing soldering to highlight your components and stands. This particular one is about $250 from Amazon, which puts it at the really bottom of the expensive stereo microscopes, but it works really well. But to the point, most everyone doesn't need this. I'm using this with 0.4 millimeter pitch soldering, so in 0402 package sizes. So not everyone needs that, especially software developers. A lot of times you may necessarily want to just go and take a picture of a component and send it to a colleague, or say, should I change this resistor value from on this pad? So with that in mind, USB microscopes that were originally targeted at children for scientific and educational purposes really have become a booming business for hobbyists, makers, and developers over the last 10 years. Strangely enough, the very first USB microscope that was on the market was manufactured by the Intel Educational Group, and it sold for about $250 and was VGA resolution. And immediately, developers and hobbyists were buying it and taking pictures of circuit boards and rework and doing soldering under it. So the market for these devices has changed dramatically. So when I'm go ahead. It's my understanding that it's fully supported with the current distribution. But one of the things that I did when I evaluated all of these USB microscopes, and I purchased about 20 different ones, ranging from a $5 one all the way up to a $200 one, was I wanted to make sure that they worked under Linux, that the resolution of the microscope was reasonable enough that I could take good, solid photos of a PCB with 0805 surface-mounted components. I also wanted to make sure that we had some way to control the light on the camera. Most of these microscopes come with LED lights on the bottom of them. Some of them are fixed. You can't change the brightness. Others have a thumb wheel that you can actually use. And I also wanted to make sure that the camera actually had a button to do a picture capture. And as you can see in this particular one, the button is actually on the side, here, and there's actually a thumb wheel to adjust the LED lights. But one of the things that I found extremely frustrating about all of these microscopes that I would get was the stand. The stand is terrible. It's a small mechanical stand that with a small screw that you tighten in order to hold it in place. And for me to take pictures of PCBs, it was very difficult to make these stands work to get consistent, square pictures of it. What I would get is, just like in this picture, it would be an offset picture. It was very difficult to get a picture directly over the device and not oblong or exaggerated. This particular camera microscope is from Adafruit. It sells for $70, and with the exception of the stand, it's an absolutely excellent microscope. The button on the side is very solid. It's got the thumb wheel to adjust the LEDs, but the stand just made it unusable for me. I still recommend it for some aspects, but what I also recommend is buying a separate stand for it. This stand is sold by Adafruit as well, and I purchased one of these, and it's absolutely lovely. You can actually buy the stand by itself and use it with other microscopes as well that come with that stand. And it holds the camera very steadily. It allows you to get good solid pictures and adjust the height on it. Yes? Right. Absolutely. I'll add that in there in the notes. But together with these two, you're talking about $120 to get the Adafruit camera microscope and the stand together. So you're talking about $120. And that's why my real preferred microscope is the Celestron version of this. It has very similar specifications as the Adafruit one. It has a picture button, has a thumb wheel to control the LED light. It's fully Linux compatible. But the thing is, it comes with a very nice stand. This particular stand, it's got springs to hold whatever you're working on in place. It has an adjustable arm that goes for up and down your Z-axis, and it's got a thumb wheel so that you can actually adjust directly on there. So you're basically getting the camera and the stand for $70. So from my perspective, it's a much better buy long term. Unless you really have a need for that swing arm stand, I really recommend this particular component. So next up is the soldering iron. And so I expect a lot of people to have questions and whether there's different types of soldering irons I recommend and everything. But really, the Haiku FX888 is like the gold standard of soldering iron stations. Don't waste your money on anything else. If you want a basic soldering station, this is the one to buy. It's extremely a reasonable price. You can find them anywhere from $85 to $100. But as someone who may not necessarily be doing a lot of soldering, you might be doing a rework of a board for your board bringer or something. Don't waste your money on a $25 or $35 fixed iron or one of the cheaper stations you find on eBay. It's worth every penny. Just buy it, and you'll never have a problem with it. Yes. Yep. Absolutely. So it's the difference between the digital calibration and analog calibration. I do recommend the digital one. The reason being that if you're using two different types of solder, leaded versus lead-free, it's really nice to know the exact temperature that you're working with. And it's very easy to calibrate this device. It's very full-featured. It has a wide range of soldering iron tips. It's carried by a lot of different distributors, including Fry's. So a lot of places you can just go in and pick one up. But from my perspective, I simply just don't recommend anything else unless you're going to a $500 or $800 rework station. There's just nothing else. And I've bought a lot of little single iron 15-watt irons. Everybody probably has seen the Radio Shack irons and Weller irons that you can get, but from my perspective, there's just nothing else. Yeah. Yep. Thanks. Yeah. Yeah, it's a standard inductive tip, but it's got the sensor in it directly. But there's like half a dozen different types of tips for it. Haku has even a pair of heated tweezers that you can get for it as well. But the biggest thing about it is, for me, I've used this particular type for like 3 years now, and compared to the Wellers and some of the other items, the tips just don't wear out like they do on the Weller. They don't oxidize, they don't bend. I can abuse the tips fairly heavily, and they just still work. And when you're doing, 0.4 millimeter pitch stuff, you have to have a really nice tip in order to get that working, and it just works well. So there was one other soldering iron that I do say that's kind of interesting. I don't recommend it to everybody, but it's interesting for one fact. The TS100 can be powered by 5 volts, either by a USB port or an external power supply. It's not a great soldering iron. The tips are fairly limited on what you can get with them, but what I do find it interesting for anyone that travels internationally, this particular iron is a godsend because most soldering stations and soldering irons are fixed at either 110 or 220 volts, and they're not adaptable. So if you buy a 110 soldering iron in the U.S. and you try to go to Europe for a conference or trade show and you need to solder up something, your iron's not going to work, and vice versa. So this one's interesting because it does run on 5 volts. It makes it easy if you're traveling internationally to adapt to the power supply. I don't recommend it as a normal purchase, but if you do travel internationally, it's a good buy to have. There's one item that I want to discuss that may not necessarily be considered as part of soldering irons, but it's a part of a soldering station, I guess you would say. This is called the stick vise by the Hackaday. It is just absolutely fantastic. I've used all these different vices and extra hands and third hands for doing soldering all over the years, and there has been nothing like the stick vise. It is just absolutely fantastic. It's a little expensive because it's kind of a niche product that Hackaday is making in lower quantities, but it's $30. It's an adjustable PCB holder. It's spring-loaded, so once you adjust it, all you have to do is squeeze the ends, and it'll release the PCB. They have a version that's 8-inch long, and I think they have an extra long version now that's 16 inches. So I keep about 5 of these around, and with different PCBs holding it. And if you're doing through-haul soldering of a lot of components, I'm sure you've found the fun of trying to hold components in place while you're trying to do the soldering. This is just absolutely wonderful, and I recommend it to be purchased as an accessory for your workstation. Okay. So that's where we're at as part of the conclusions here. Go ahead. Absolutely, and I normally keep a wide range of them. Again, Fry's generally for the Haku has probably 15 or 20 different variations. They're fairly inexpensive, so it's a good investment just to pick them up in case you need them. So that kind of brings us to the conclusion here. There are some good bargains out there that are less than $100 that help you kind of keep your workstation functional. But you have to be careful because a lot of times you often get what you pay for. Your expectations need to be right where you're at, around what you're paying for. The DSO 1112, it's well worth the $70 to do basic debugging. But if you're expecting to debug HDMI with it, it's probably not going to match your expectations. Look through all of the reviews. For the low-cost items, there's surprisingly a lot of reviews and people talking about how their experience with a particular device was. Used eBay, look at previously sold items. That's really important. Another really interesting thing is YouTube videos. There are a lot of YouTube videos popping up of people unboxing things and giving reviews of it. And generally, I found that they're fairly accurate on their reviews. So it's easy. Just Google out there and see if there's a YouTube review on a particular part before you buy it. And if all else fails, go ahead and ask a friend. Don't be afraid. I know that from a perspective of talking to a lot of my hardware-challenged programming friends, sometimes they're a little shy on asking about some of this type of stuff. So don't be afraid to ask a hardware guy, what's your opinion on a particular item. Do you have a question in the back? It's all. So the question is, which type of chip or tip would be the best to get? It all depends on what you're soldering. Remember, these are tools. You don't ask for a Phillips when you need a flat. So, when screws, or if you're cutting something, you don't try to use a hammer. So it's all about thinking of it as a tool. Generally, if you're doing very fine pitch, 0.5 millimeter, or you're doing surface mount components, a conical tip will be a much better choice. If you're doing a lot of through-hole components, the chisel tip is much more important to spread the heat across the larger through-hole pad areas. So it's very dependent on what you're working with. That's why I recommend go ahead and buy a few different ones. Yeah, for desoldering, it's very straightforward on a lot of that. We have desoldering braid that's available, and that's very easy to work with. There's a lot of great YouTube videos on how to use desoldering braid. The other one's the vacuum solder suckers, and those are fairly common. There's not much variation in the quality of it. There are some hot air rework stations that are available, but they generally don't start until you're talking about $250. So again, it's very dependent, but basic desoldering stuff, you don't see much variation in the quality of them. Right. Yeah. The problem with most of those is that they will over temperature the PCB very quickly and do damage. And one of the worst things you tell people that do old arcade game restoration is tell them that you use one of these desoldering bulb suckers on, because it really destroys the boards quickly. I've not found one that's really good at that. Occasionally there's a couple of refurbs that get posted on eBay, but I've not found a new out of the box, and I'm not keen on the refurb. So I just don't know of a good one, and yes, I've been looking. So to summarize there, if you don't know about these particular things, don't be afraid to ask somebody, whether it's on IRC, email, or a friend that you know. All of the documentation will be up later today on the elinux.org website, as well as links to all the devices that are discussed. And again, this is not a be-all, end-all list of stuff, but these are just some of the things that I found over the years and through my testing that really makes it easy, especially for a software developer who may not necessarily know which items to purchase. Thanks for attending. Oh, go ahead.
Thanks for buying all this stuff.
Yes, I just said.
So links will be on the
eLinux. So I'll have all the links up on eLinux as.
You have the information on the links, so everything. No, thanks.
I'll have the links as well. Yes. Yeah. I'll have it as a placeholder, so I'll have it up later. Were there any other questions that I could answer? Yes. Yes, as a matter of fact, there's a project right now for the icepick, the lattice development platforms. They've been reverse engineering the protocol to program those. So Google open source icepick. It's I-C-E-pick, P-I-C-K, and it's very functional. It's not as a complete. You have to remember it's an early on reverse engineering project. But it's a very nice, and it has a lot of potential. I don't know the details on that. I know I've downloaded and done some testing with it, and it's fairly robust. But I don't know what their overall intent is going to be. Yeah. Again, thanks for attending. If you have any questions, let me know.